Look at the idea of density. In lab, you investigated how the mass of the block depended on the volume of the block, and you probably got a relationship that looks something like this, which you can fit with a straight line. Obviously, the data doesn't fit perfectly because there was some variability. It was difficult to measure the volume exactly, but I think you can tell that this is a straight line. It's not curving, obviously, in one way or the other. And the intercept is 0, and it makes sense that an object with no volume would have no mass. So we are going to say that they're proportional. So in this case, we can write y is equal to the slope times x. On our y-axis, we have mass. On our x-axis, we have volume. And we are going to label our slope rho. So in physics, we're going to use the Greek letter rho, which is like the Greek equivalent of r, as the symbol for density. Okay, so I think in chemistry you use d for density, but we use d for distance everywhere in physics, so we're going to use rho. Okay, so I think this is what you found in lab. The mass is equal to some constant times the volume. That constant we're going to characterize as the density. So the density is the ratio of the mass of the object to the volume of the space that it occupies. So a large density means there's lots of mass in a small amount of space, and a small density means there's not very much matter in a given amount of space. So in our toolbox, we're going to put this in. Go ahead and pause the video if you need to. Put this in your toolbox. The rho is just like sort of like a P, except it's kind of slanted, and so it looks like that. All right, resume when you're ready. Okay, so the way we measure density is in units of mass divided by units of volume. So one way is to measure it in grams per centimeter cubed, that's a unit of volume, or we could measure it in kilograms per meter cubed. And we could also measure it in other units. Pounds is actually a unit of force, so we can't use pounds, but we could use slugs per cubic foot, for example, but those aren't very common. So an interesting fact about density, we use water as the standard reference in order to find mass. So we define mass, 1 gram, as the amount of matter contained in 1 cubic centimeter of water. So if I take a cubic centimeter of water and I find out how much matter there is in there, we define that amount of matter as 1 gram of matter. Okay? So that means the density of water is defined as 1 gram of matter in every centimeter cubed of water. And that's at standard temperature, standard pressure, and that's liquid water. So the density of water, although it's 1 gram per centimeter cubed, there's a couple other ways we measure it. So if you imagine a 10 centimeter cubed by 10 centimeter cubed by 10 centimeter cubed block, that's actually 1,000 cubic centimeters, and 1,000 cubic centimeters is also 1,000 milliliters. So the volume 1 milliliter is the exact same as a centimeter cubed. And 1,000 of those is equal to 1 liter. So it turns out that 1,000 centimeters cubed would have a mass of 1,000 grams, which is a kilogram. So a kilogram of water, the kilogram is defined as the amount of matter in 1 liter of water, or 1,000 cubic centimeters. We can do a quick little conversion here. If I take the density of water as 1 gram per centimeter cubed, I can get rid of the grams because there's 1,000 grams in a kilogram, and I put the grams on the bottom down here to cancel. That's going to leave me kilograms per centimeter cubed. I want to get rid of centimeters and convert it to meters. There's 100 centimeters in a meter, but because this is centimeters cubed, I've got to cube the conversion, so that ends up canceling that. And so you get 1 divided by 1,000, and then times 100 cubed ends up being 1,000. So the density of water is 1 gram per centimeter cubed, and it's also 1,000 kilograms per meter cubed. So if you imagine a cubic meter, 1 meter by 1 meter by 1 meter stick, that much water has a mass of 1,000 kilograms, which is about 2,200 pounds, which is what we call a metric ton. So a ton is 1,000 kilograms. So the density depends on a lot of things, like temperature and whether it's in liquid and gas and stuff. But for the most part, the density of a substance is constant. And you can look it up in a table. And so this is the table we're going to be using. You'll have access to this during all the homework problems. It's got the density in 2 different systems of units. So just make sure if you're solving the problem in grams and centimeters cubed, you use this density in the second column. If the problem's in kilograms and meters cubed, you're going to use this density in the first column. Okay? So you can see that, for example, metals tend to have a high density. Copper is 8 grams, or almost 8.9 grams in a centimeter cubed, all the way down to water, which is 1, and then some things like air and oxygen, helium, they all have mass. It's not very big, but it's not 0. There is a matter in a cubic centimeter of air, and you can look up and see how much matter there is. So there's 0.00129 grams of matter in 1 cubic centimeter of air. So we're going to have this table and use it. So here's an example problem you might be asked to solve. Suppose you have a cube and the edge is what you're after. So it's a cube of aluminum and its mass is 100 grams. So since we're using aluminum, we're going to go to aluminum here. And since we're using grams and centimeters cubed, we're going to use 2.7 as the density of aluminum. So here's a little diagram. It's a cube and the edge length is L. I know the mass is 100 grams, and I know the density is 2.7 grams per centimeter cubed, and I want to find the edge length. Well, that's going to require 2 steps. First, I have to find the volume. So I'm going to solve the density equation for the volume, and if I do that, the volume will be mass divided by density. So to solve that, multiply both sides by V, and then divide both sides by rho to get the mass over the volume, over the density is the volume. And after I find the volume, because this is a cube, I'm going to use the fact that the volume of this cube is equal to L times L times L, or L cubed, and I'm going to solve that equation for L. So it turns out L is the cube root of V, but of course V is m over rho, so I can write it as the cube root of m over rho. I can plug in my numbers. I'm going to take 100 divided by 2.7. That will tell me the volume. Take the cube root, and that'll tell me the length of one side. You might want to pause the video and just check it yourself. And it turns out the answer is 3.3 centimeters. So if you look at a ruler and you think about a cube 3.3 centimeters on an edge, that would be the edge length of a cube of aluminum that has a mass of 100 grams. Okay, so you're going to use a lot of the formulas from geometry, for solid geometry. The volume of a sphere, the volume of a cube, the volume of a I don't think there's any pyramids involved. The volume of a rectangular prism, for example, length times width times height. So you might need to review those as you solve these problems. Okay, good luck.